Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P2623 indicates a malfunction related to the high-pressure fuel pump spill valve in a 2015 to 2020 Honda Fit. The high-pressure fuel pump is responsible for delivering fuel to the engine at the necessary pressure for optimal performance. The spill valve's role is to control the fuel flow back to the fuel tank, preventing excess pressure buildup. If the valve malfunctions, it can lead to engine performance issues, fuel efficiency declines, or starting problems. This code can be triggered by problems ranging from electrical faults to mechanical failures in the fuel pump system. Before starting the troubleshooting process, it's recommended to review the general troubleshooting information for context. The high-pressure fuel pump spill valve, which is highlighted in DTC P2623, is a vital component in the fuel delivery system. Its main function is to redirect fuel back to the tank, thereby regulating the pressure within the fuel lines. This component is usually located near the fuel tank, where the high-pressure fuel pump is installed. When the valve malfunctions, it can disrupt the necessary fuel flow, leading to various engine performance issues. The malfunction can also affect the fuel control module's functions, prompting the engine control unit, ECU, to register an error. Understanding the role and location of this component is key in effectively troubleshooting the DTC. The possible causes of DTC P2623 predominantly include electrical faults, mechanical failures in the fuel pump system, and poor electrical connections. Electrical issues can arise from short circuits, open circuits, or damaged wiring associated with the fuel pump's spill valve. Mechanical failures might stem from internal wear or damage in the spill valve itself, which can compromise its functionality. Poor connections, such as corroded or loose terminals, can lead to inconsistent signals being sent to the engine control module, ECM. Each of these issues requires thorough inspection to determine their specific impact on the spill valve's performance. A malfunctioning high-pressure fuel pump spill valve can manifest several symptoms that can be crucial for diagnosis. One of the primary symptoms is the possibility of the engine failing to start, resulting from improper fuel pressure. Additionally, you may notice reduced fuel efficiency, which might indicate that the spill valve is not managing the fuel return correctly. Other symptoms could include poor engine performance, such as hesitation during acceleration or unstable idling patterns. Identifying these symptoms can guide technicians to further explore the high-pressure fuel pump system, specifically focusing on the spill valve for potential faults. The first troubleshooting step involves initiating the vehicle's on mode and utilizing the HDS, Honda Diagnostic System, to clear the DTC. This action can reset any temporary glitches that may have triggered the malfunction code. After clearing, start the engine. If it doesn't start, try cranking it for 20 seconds to ensure the fuel system receives adequate priming. Once this step is complete, check for any pending or confirmed DTCs. If you find that DTC P2623 is still registering alongside other injector-related DTCs like P0201 to P0204, this indicates that there may be additional faults present, thereby guiding further troubleshooting procedures. Step 2 requires the vehicle to be turned off completely before proceeding. Begin by removing the injector relay from the underhood fuse relay box, which is crucial since this relay can significantly affect fuel injector operation. Subsequently, the relay's functionality should be tested using appropriate diagnostic equipment. If the relay is functioning correctly, you will proceed to the next troubleshooting step, which delves deeper into the wiring and connections related to the fuel pump system. If the relay fails the test, it will need to be replaced to ensure proper fuel system functionality. For the third step, Switch the vehicle to the on mode with the injector relay still disconnected. Measure the voltage between test points, particularly between the injector relay 4P socket number 3 and body ground. You need to verify if battery voltage is present at this junction. If voltage is confirmed, it indicates that the FI main RLY out wire is functioning as it should, allowing you to proceed to the next troubleshooting steps. Alternatively, if there is no battery voltage, this suggests there may be an open circuit in the FI main RLY out wire that will require repair, potentially involving the replacement of the underhood fuse/relay box. The fourth step requires the vehicle to be turned to the off mode. You will proceed to measure the voltage between test points, specifically assessing the injector relay 4P socket number 1 against body ground. This test needs to be conducted with the injector relay disconnected. If you find battery voltage present, this confirms the +B hinge wire is functioning, and you can move to step 6. Conversely, if there is no voltage, take note, as you'll be directed to step 5, where the focus will shift to checking specific fuses that may influence circuit functionality. In step 5, you will inspect fuse number B10, rated at 20A, located in the underhood fuse relay box. This fuse is critical as it impacts the injector relay's operation. To check its status, pull the fuse and inspect it for any signs of damage or breakage. If the fuse remains intact, you will need to repair any open circuit in the +B INJ wire, focusing on the section between the fuse and the injector relay. Conversely, if the fuse is found to be blown, repairs on the short in the +B INJ wire will be necessary, and the blown fuse must be replaced for the system to work correctly. In the sixth step of troubleshooting, turn the vehicle to the on mode, ensuring the injector relay remains disconnected. Measure the voltage between test points, particularly between the injector relay 4P socket number 3 and number 4. This measurement should account for a momentary check after the vehicle is switched to on mode. An affirmation of battery voltage would mean the INJ RLYCL wire is functioning correctly, allowing you to continue to step 8. However, a negative response would necessitate checking the continuity in the wire, specifically focused on the section linking the injector relay and the PCM. Step 7 calls for the vehicle to be turned to the off mode. Begin by jumping the SCS line with the HDS to ensure proper diagnostics. Next, disconnect the PCM connector A, 51P. This action is vital to isolate the system and prevent false readings. Proceed to check for continuity between the injector relay 4P socket number 4 and PCM connector A, pin number 15. If continuity is established, it confirms the health of the INJ RLYCL wire. If the continuity check yields no result, it will require repair for open circuits within that section of the wiring, ensuring the connection between the relay and PCM remains intact. Proceeding to the 8th step, ensure the vehicle is in the off mode before continuing. Jump terminals A and B within the injector relay 4P socket. This method allows you to simulate conditions for testing. After establishing the jump, disconnect the PCM connector A, 51P. Measure the voltage between the appropriate test points, specifically looking for a response from socket terminals number 6 and number 7 against body ground. If battery voltage registers, it confirms the INJ RLI out wire operates normally, allowing you to advance to step 9. Absence of voltage suggests an open wire issue that needs repair. In this 9th step, reinstall the injector relay before proceeding. Jump the SCS line with HDS to prepare for continuity checks. Disconnect the PCM connector C, 51P, to ensure accurate readings for the upcoming tests. At this point, check for continuity between the PCM connector C, pins number 13 and number 14. This verification ensures that both H-pump H and H-pump L lines are functioning properly. If continuity is verified, you can then progress to step 10. While no continuity indicates a break in the wiring that needs immediate attention and repair. At step 10, disconnect the high-pressure fuel pump 2P connector to isolate the system for a specific test. Confirming continuity is the next primary action, which involves checking between the test points designated for the high-pressure fuel pump connector and PCM connector C pin number 13. If continuity exists, it suggests that the H-pump H wire is intact and functioning correctly. This finding allows you to move on to the next step in diagnostics. On the other hand, lack of continuity indicates a fault requiring repair in the H-pump H wire section connecting the high-pressure fuel pump to PCM. Step 11 centers around the assessment of the H-pump L line's continuity. This requires measuring from the high-pressure pump 2P connector to PCM connector C, pin number 14. A continuity verification here indicates that the H-pump L line is operating correctly, allowing for further movement in checking the system's overall integrity. If a fault is detected, repairs will be needed to address any issues within the wire, ensuring proper connections to support effective fuel delivery. If the PCM requires updating or substitution, this opportunity must be taken before finalizing the repairs. Step 12 involves turning the vehicle to the on mode after disconnecting the high-pressure pump 2P connector. This method enables you to measure voltage to diagnose potential shorted wires within the H-pump H line. When you check the voltage across the specified test points, you are looking for any signs of voltage indicating a short circuit scenario. If voltage is present, it signals an issue that must be addressed immediately by repairing the short to power condition within the H-pump H wire. Absence of voltage suggests the wire is intact, but does not provide enough information about other potential faults that may persist in the system. In the 13th step, you will again check for voltage, but this time focusing on the H-pump L line. Once the high-pressure pump 2P connector is disconnected, repeat the voltage measurement process across the specified test points. Finding voltage indicates a short-to-power condition that must be repaired in the H-pump L wire, connecting the pump to PCM. If no voltage is detected, you can progress to the next step. However, it will be essential to document any findings for a more complete diagnostic overview of the entire fuel delivery system. Step 14 will require you to once again turn the vehicle to the off mode. You should conduct a continuity check on the H-pump H line to determine its health. This comparison entails measuring between the PCM connector C, pin number 13, to ground. If continuity is established, it means that the wire is functioning as designed. However, if no continuity is detected, repairs will be necessary to correct any existing faults in the H-pump H wiring that may be impacting the high-pressure fuel pump's operation. The final troubleshooting step focuses on assessing the continuity of the HPUMP L line once again, ensuring that a robust connection exists between the high-pressure fuel pump and PCM. If continuity is confirmed, it denotes that the wire remains operational. If no continuity is found, intervention will be necessary to address any shorts within the wiring. Additionally, it's important to determine if the PCM has the latest software version. If not, updating the PCM or substituting it with a known good unit can result in eliminating DTC P2623 and restoring functionality to the system. After completing the necessary repairs following the troubleshooting process for DTC P2623, it's vital to perform a final verification procedure. Begin by clearing the DTC using the HDS to ensure any stored codes are erased from the ECU's memory. Conduct a test drive to allow the vehicle to reach normal operating conditions, which will provide insights into the effectiveness of the repairs. Monitor for the recurrence of DTC or related symptoms. If no new faults are registered, the repair can be deemed successful, confirming that the fuel pump spill valve and associated circuitry are functioning properly. Effective preventive maintenance can mitigate the risk of DTC P2623 and related issues in the future. Regular inspections of the wiring associated with the high-pressure fuel pump system can reveal potential wear or corrosion points before they escalate. Ensuring that all the connections, including those at the fuel pump and spill valve, remain secure can significantly improve reliability. Additionally, keeping the PCM software updated creates a more responsive and efficient fuel management system. Maintaining these components in good condition can aid in early detection of issues and prolong the vehicle's longevity. In conclusion, addressing DTC P2623 related to the high-pressure fuel pump spill valve requires a deliberate and systematic approach. Recognizing potential symptoms, such as starting issues, reduced fuel efficiency, and engine performance irregularities, can guide diagnostic efforts. A thorough inspection of electrical connections and wiring, as well as component functionality, establishes a reliable fuel system. Proactively performing preventive maintenance can ensure longevity and reduce the occurrence of this and other related issues. By embracing these strategies, owners can maintain their Honda Fit in optimal operating condition for years to come. Please like and subscribe to the channel. See you next time.